Hello, welcome to Chemistry 101 tutorials. If it's your first time joining us, please go down below and hit that red subscribe button. Okay, so let's jump into today's tutorial questions. Calculate the limiting reactant if 5 grams of ethane react with 7 grams of oxygen in a combustion engine. First thing first, write a balanced chemical equation. Okay, so in this case I will just write a balanced chemical equation, and if you want to learn how to balance equation, please go to the description box, to the description below, and I'm going to put the link from my previous video. Okay, alright, so this is a balanced equation, and one thing for sure that you have to keep in mind is that if you are told that it's a combustion reaction, in this case the hint is that this is happening in a combustion engine. That means it's a combustion reaction, and the product of combustion reaction is always carbon dioxide and water. Okay, so this you do not have to forget. Sometimes the examiners will just ask you, okay, this is a combustion reaction, but they don't tell you the product. So the product is always carbon dioxide and water. All right, so now the next step is to calculate how much product will be produced if 5 grams of ethane react. Okay, and you will also do the same also for oxygen. Okay, so in this case we will start with ethane. So now I'm going to calculate only for carbon dioxide, and you will do that. You'll do the calculations for water. Okay, but in each case, even if we consider carbon dioxide as the product or water, the limiting reactant will always be the same. You will do that with the water, and I'm gonna give you an example with the CO2. Okay, so let's start. So in this case you have 5 grams of ethane. So convert first to moles. So 1 mole of ethane, 6 divided by molar mass, which is 30.1 gram ethane, multiplied by the mole ratio, which is 4.4 mole CO2. This 4 mole is actually from the equation. Also the mole ratio, the coefficient here is 2, so I'm going to divide that with 2 mole of ethane. Okay, so this and that will cancel out, and grams of ethane will cancel out. Your answer will be in moles. In this case we will further convert it to grams. So in this case we will multiply with the molar mass of carbon dioxide, which is 4 grams. 1 mole CO2. So in this case this and that will cancel out, and your answer will be in grams, which will be 14.6 grams of CO2. Okay, sure, yeah, that's it. And now let's calculate for oxygen in this case. Okay, so it's gonna be the same steps. So create space here. So we have now 7 grams of oxygen. Now first convert it to moles. So 1 mole of oxygen over the molar mass of oxygen, 2 grams oxygen. So that will cancel out, and then again with the mole ratio. Okay, mole ratio, the coefficient of oxygen there is 7, so that means 7 mole of oxygen multiplied by, we take the answer 2 grams, so 44 grams CO2 over 1 mole CO2. Okay, the answer here will be 5.5 grams of CO2. Okay, so which one is the limiting? So the limiting is the one that give rise to less product. So in this case oxygen is the limiting reactant. Okay, oxygen is the limiting reactant, so that means carbon dioxide will be in, that means ethane will be in excess. Okay, alright, so we are done with the first question. So then let's go to the next question. How much is the amount of CO2 produced in grams? So we just did the calculation for CO2, and in that case we have 14.6 and 5.5. But as I've already told you, in this case here, we are going to have the amount of CO2 produced in gram as 5.5 grams of CO2 will be produced. So this is from the limiting. So your limiting reactant always determine the product. For example, let's say we have A plus B forming AB. So let's say A is girls, so we have 7 girls, okay, girls, and let's say B is boys, so we have 5 boys. How many couples will we have? In this case, the number of couples will be determined by the limiting, which are boys. So the boys are less in number as compared to girls. So in this case, we'll have 5 couples and 2 girls will remain without a boyfriend. Okay, so how many couples again? As a product, you will have 5 couples. So the product is always determined by the limiting reactant. Okay, so in this case, your product will be that one, which was determined by the limiting reactant, which in that case was oxygen. Okay, so the next question, how much is the excess reactant in grams? So already the excess in this case is ethane. Okay, so in this case you will calculate how much ethane will react to form 5.5 gram of CO2. all right, so that means you want to find out how much will react, and then after finding how much will react, then you will subtract it from the starting mass that was put in the combustion engine. Okay, so let's do that. We have 5.5 gram of CO2 multiplied by 1 mole CO2 over, so we take it to the molar mass, multiplied by, so now the mole ratio will be this case 2 mole 4 mole CO2 multiplied by 30.1 gram of ethane, that is the molar mass, 1 mole 6 H there. Okay, yeah, I hope you can see that. And here the answer will be 1.9 gram C2H6. So that means 1.9 actually 1.9 grams of ethane is going to react. Okay, so in the combustion engine, how much did they put? They actually put 5 grams. Okay, so then how much will remain, which is the excess? So that means we have to say subtract it with the amount that is going to react, which is 1.9, so the excess will be 3.1. okay, so the 3.1 is going to be the excess. So in that previous example, that means it's going to be the girls. Okay, so this is how to calculate the limiting reactant, and I hope you enjoyed this video, and if you enjoyed, please give it a thumbs up and also comment down below. I'm going to put a homework, and please try to practice and again put the answer in the comment section below. All right, okay, yeah, thank you for watching this video. Yeah, I'm going to upload another video again tomorrow. Yeah, so bye bye, wish you more success.